Okay, so why do we care about calculating that variance that you just derived? Well, it turns out there's another way that we could scale or standardize the residuals, and that's something known as a studentized residual. And so what that does is it takes yi minus yi hat with this little in parentheses I, which denotes that we have left out observation I when we fit this model. And then we divide by that variance that you just calculated, the square root of that. And so this quantity here is going to have a t distribution with n minus 1 minus p plus 1 or n minus p minus 2 degrees of freedom. If this model is correct and your epsilon is normally distributed with a mean of 0 and a variance of sigma squared times the identity matrix. And so this is kind of a helpful way to be able to think about the residuals. And as you maybe saw when you were trying to calculate that last quantity, it can be kind of cumbersome to have to refit your model for every single, like leaving out one observation at a time. Of course, you could automate this. You could write a function to do this. But it turns out for linear regression, there's actually an easier way to compute these standardized residuals. And so it turns out that residual is going to be exactly, or the studentized residual is going to be exactly equal to Ri, where Ri is the standardized residual, times n minus p minus 2 divided by n minus p minus 1 minus the ri squared, where ri squared again is that standardized residual. And then that whole thing raised to the 1/2. And so I want you to go ahead and calculate the studentized residuals for the data above, for each of the data points, using that equation on the previous slide.